Very much welcome to all of you who are joining us today. Today is Tech Tuesday with the Combitech, and Tech Tuesday is, as you may know by now, a collaboration between Linköping Science Park and Combitech, Sectra, Ericsson, SICK IVP, and Nira Dynamics. The event is held around every third Tuesday. My name is Frida Enebro, and I work as a communication officer and event officer at Linköping Science Park. And we are at Go to 10, which is a co-working place owned by Internetstiftelsen. And you are all very much welcome to register so that you can sit here and work for free whenever you feel like it. Today, we are going to hear Jan-Dirk Weber talk about how autonomous fleet management can help mining operators increase the value flow and reduce human exposure to dangerous, monotonous, and lonely tasks. By applying autonomous technologies, we can optimize machine utilization, energy consumption, and by that resource usage leading to sustainable operations. This presentation will be recorded and will be put on our website later on. If you have any questions, feel free to ask them afterwards. And those of you who are online, just write your questions in the chat and we will ask them for you. And now, Jan-Dirk.
Thank you. All right, my name is Jan-Dirk Weber, and I am with Combitech as a product development leader. In this program, my role is an operative product owner, and I, together with teams, are working on the mining management solution, which I will talk about today. And together with our partner Epiroc, we have, for about 5 years ago, we started to go into autonomy in underground mining. So just a primer question to you, so that you get going. What does autonomy mean to you? Because it may vary quite a lot depending on who you ask. When we started 5 years ago, we realized that it's not a simple answer. We have, of course, the main part here, the blue side of the cube, where we have the vehicle system, all the things, the sensors and controls which are close to the machines. And then we have our part. We have been working with the fleet management and traffic management parts, and also to some extent the integration towards the Epiroc safety system, because having those autonomous machines working in a confined area, you need to have a safety system. And Epiroc wanted to give the possibility to the operators to easily access the safety system and flexible change the safety areas where autonomous things can happen. Between the two systems, the vehicle system and the traffic management system, we have been working with a interface called UPCUA, which is a standardized framework, you can say, and that came from Epiroc, or they used the UPCUA framework and defined their interface on top of it. And we did not stop there. We also integrated towards mine infrastructure. For example, if certain areas are not allowed for autonomous machines to enter, like at the crusher, if the bin towards the crusher is full, or if a rock breaker is out of parking position and the autonomous machine would damage the rock breaker, then we stop this from happening. And we did not only integrate Epiroc machines, but also from a Canadian vendor, McLean. There they provided a block hauler and a water cannon. If, for example, draw points get stuck, then you need helping machines to free them again, to make them accessible for the loaders. There was also a need for having, for example, manual-driven vehicles to get the location of those into our traffic management system. And there was a cooperation with an American company called ASI, and they developed so-called ASI pods, which then could be put on pickup trucks or other machines. For example, also on this Warthog, which is more like a small robot type vehicle used for scanning the mine and looking for problems in the structure. We also integrated towards a Bobcat, which you may know. They are driving around on the streets sometimes as well here. And then, of course, we have the integration towards some kind of operational flow or orchestrator of the complete mine. This is mainly controlled by geologists, how the ore body shall be worked on, that it collapses in a certain way, safe way. And here we have had two examples. We have the OMI, Open Mine Integrator, that was a cooperation with LKAB. I will come to that a little bit more. And we have ORB, optimized real-time bugging. This system then helps the geologists to let the ore body collapse in a safe way. I will talk about a little bit more around that. So, but that was only one side of the cube then. We see also that we really need to drive standardization in this industry. Because it would help to, for the mine operators to have different vendors cooperating in the mine and have them competing with each other also. Safety, of course, is a big thing in mining, and as I said before, we are working still in confined areas where the autonomous machines are then allowed to work, and that helps to not have any dangerous interactions with humans. And it's an important business, so security, of course, plays a role there as well. Very essential, of course, we need to know where the machines are and to be able to control them. So positioning is a key factor. And also the data infrastructure, we need to exchange information. And then a big thing, of course, is to facilitate that connectivity, mainly provided by Wi-Fi in most of the mines we have been working with, but maybe more and more mobile systems as well. So I would like to talk a little bit about our digital trip. We realized that what are the enabling factors for autonomy then? First of all, I mean, we need to collect information. Without that, it is not possible to have any autonomy at all. Going into the y-axis here, level of automation, we have the first step is then remote operation. Then we can go further, or meaning that you have terminals, remote control, you have video, you can steer the machines from above ground in a certain area. Isolated automation would mean that you can send the machines from A to B in a particular area, but most of the times you have just one machine working in a designated area. Isolated autonomy means we have one machine type, as I will show in that example, the demo later on. We have several scoop drums, for example, working in a area where they share a certain part of that area, and we need to control that the machine will not damage each other. And later on, we will come to collaborative autonomy. For example, if we get the complete flow of ore, we can take the ore from with a scoop drum, put it on a mine truck, and then deliver it to a crusher, and then up to overground. On the x-axis, we have then that we can exchange information. We can have automatic decision support, like as I mentioned before, we have those integration towards the mine infrastructure that we decide that an autonomous machine shall not enter a certain area because of certain conditions. And that can be done, of course, that complete processes are integrated, and then later on, complete system of systems. If we take a look on our journey through the steps here, in 2017, we started off with a proof of concept together with Epiroc, mainly about if we can work together in a good manner, and we did. And what the task back then was that we had two ST8 teams working together in an area, sharing a certain part of the area in a very simple setup in a test mine close to Örebro. But we also did a POC, more fleet management system, like where we had information gathered and then orders or assignments put on towards tablets which were located on trucks or loaders in a mine in Chile. But unfortunately, that part we did not go along for some marketing reasons within Epiroc. But in 2018, then we got this customer in Australia, Newcrest, and they had this mine called Cadia, about 200 kilometers west of Sydney. And they, together with Epiroc, decided, okay, let's do something big. Let's automize get some autonomy in this mine called Cadia. So we started off with just 2 extraction drives to have the loaders, very similar to the POC, which we did before. And then we went along towards that we did it for the complete mine. I will show you the picture later on and also give the demo about it. And that continued for some years. We also integrated, as I mentioned before, the EPROC safety system to make it flexible of how you divide your work area into smaller autonomous areas. And now we are in the 3rd release of our system, and we approach the situations that we now have interactions between scoop tram, the loader, and the mine truck. So, but yeah, we have we are touching here the autonomous fleet management system. So coming to the first case, that is the mine in Australia called Cadia. It is a block cave mine, meaning that the ore body the ore which you would like to extract is above your infrastructure. So it takes quite some time to build the infrastructure. You need to go down here all the way, 1,200 meters. And then you build the infrastructure, as you can see here from above. The extraction drives from north to south, and then here you have the draw points, which are highlighted as darker circles, and those can be approached from both sides from the extraction drives. The loading is done manually, and then the loaders are autonomously driven towards the crusher, which is here on the southern part. And here in this area, the machines share the traffic zones, and we need to make sure that they don't disturb each other. As you can see, it's quite a big ore body. The green parts are the best quality of ore. Blue, dark blue is still a good quality, and then you have less quality. I think right now we have 1 gram of gold. It's a gold mine, 1 gram of gold in 1 ton of ore. So I think that is also quite interesting. Or when I started, I did not realize how much energy and effort we are putting into getting this raw material out of our earth. So that was quite astonishing for me, at least. And the caves here, PC1 and PC2. The PC2 is 300 meters below to the east of PC1, and they are in production since 2013 and 2015. When we started 4 years ago, then Newcrest realized that the mine approached, or this panel cave approached, end of life, and it becomes more and more dangerous to have humans here on that level, because the ore body is grained down by gravity and it becomes more or less sand. And if you have a setting, then you can have storm winds in those tunnels here, and they crush everything what is in their way. So that was one of the reasons we started. Another, of course, was you need to go down to those levels every time you you have a shift change, and the manual operators needs to go down there. So it's much more convenient for them to sit above ground and not alone, as you can see here. So that's a typical setup for a mine operation center. Here you see our system, the mining management solution, as it is called for now. Here you have the operator station with all things directly related to the machines. You have the LiDAR with visualization, the readings here, and you have a video here. Here it is better to see a video stream, for example, if you need to manually load the bucket. And then here, the operator has an interface towards ORP, because ORP is not only used for the automation part of the mine, but also for the manual parts. And if the operators are on the machine, then they get this information on their tablets on the machine. And here's some system for interacting with the showers to minimize the dust which may occur when you work with an ore. Here you can also see a picture for the crusher where all the machines put their material into. The second example is more about collaborative autonomy. So we have here in those areas where the scoop drums, the loaders are working, and here you have then the mine trucks which are on that road to get loaded on those load transfer points, and then that they go up to the surface with the load. Here you see also two different mine layouts. I think this is the traditional layout, and here you have more like a fork layout, which they wanted to test. And here it is also that the loader can go backwards. Here the mine truck can come, and then the loader can put the material into the machine. Here it must turn coming out of the draw points. And the idea was also not only dividing into two different machine types, but also for assigning the areas to different machine vendors. And then to have a coordination of the different systems on top of that, so that they can work together. So here just one more overview of the complete system. I think this naming will also change in some future here, but back then it was called Scoop Drum Automation Total. We had also the possibility to put our client on a PC tablet that is quite convenient for mine operators, which needs to be at the level, and then to see what's going on here in the mine, and also to be able to follow, for example, a check-in procedure for a machine, or and knowing where the other machines are. Good. And now I would like to continue to the demo. All right, so let's take a look a little bit on our application, which we have been working with about 4 or 5 years now. And what can you see here? We have on the left-hand side, we have the assignment flow. You can create assignments. For example, I can choose Layla here to go to point, for example. Then I will get a create assignment panel with information about the assignment up here. And I can then choose a destination and create assignment, and let's launch it. Here you see that Layla is moving, and the orange colored part of the route is meaning that, yeah, the vehicle got access to that part of the route. In general, I have ST18s here, which means that they are supposed to take 18 tons into this bucket. And I have also an rock breaker, ST14 rock breaker. I will use this vehicle then to interfere with the autonomous movements of the machine later on. So what else can we see? As I said before, we have been integrating our mining management system towards the EPROC safety system. This we have displayed here, that the safety area is up by the blue border of the extraction drives, all the drives. You can see that here on the northern side, we have barrier cabinets, which are have the function of entrance. So you can check in machines through those light barriers here without actually interfering with the traffic. So the traffic still can go on because we have 3 light curtains here, so that at each given time, we have at least 1 machine length between automation area and possible human location. We have also here barriers which are not used right now in the configuration, they are contained and unarmed barriers. I will not show the complete process in the flexibility of the system, but let's assume that we would like to just have the left-hand side of the mine, or we would like to split those in 2 areas. So if I just then would choose this one here, then the operator gets a lot of tasks to perform before such a change of safety area is possible. Certain machines need to be checked out, all the machines which are outside of the area, because it is not, they are not longer under a certain safety area at the moment. But of course, we can then put another safety area on top of them, and then they can be checked in again. And also, I need to make sure that those machines which are within the new safety area configuration, I need to confirm position to really make sure that they are where they are, or we would like to have the confirmation from the operators that, yes, they are where they are. And then we have also the information that this barrier, which was a contained barrier before in the complete setup, we will change to a shared barrier, meaning that on the other side, we can add another safety area. I will not go further with it because it's a lot of machines which I need to confirm or do something about. It would take too much time. But if we then look at the scenario I have already taken away the right-hand side. So only the left-hand side is active. And then I can put over a new safety area configuration over those machines. And then I have split the area in two. Or I can just, for example, if we got stuck in a certain draw point here, I could just choose to have a single extraction drive as a safety area, and I could put in a water cannon or block holder to free the draw point again. I will put out safety areas for display right now. And I will start up all the machines here. There you can see that you have the white dashed lines that are the intentions where the machines want to go. And then you have the orange solid lines where access is granted for certain parts of the route of the vehicle. I need also to add that all the routes are pre-recorded and then commissioned. So you start off with a quite slow speed, and then you higher the speed in steps. And then you end up with a speed where the machine still can follow the intended route without problems. So a lot of things are going on. We also display for your own assignments, we display the manual tasks. So that the operator knows, okay, something needs to be done here. Now I own all the machines, so it's quite crowded. Usually an operator has one machine, at max 2 machines. And I also forgot to say that, for example, if we receive the orders from ORP, the overlying system there at Cadia, then those assignments will come into this box as unassigned assignments. And the operator, which is controlling the machine, can take over and assign it or take on ownership of the assignment. And you see at times the machines are turning to white. That means that they are operated in teleremote. And if they are in green, then they are autonomous. What you can't see is if they are orange and mainly outside of the automation area here, then they are driven manually. So if I now try to interfere a little bit, I need to wait until the machine is down here. Okay, I can, of course, start. That you believe me that the machine will stop? So like this. And what we realized quite early that we not only developed the application, which you see, we also developed a complete mine simulator or a simulator of the operator station, for example. The mine simulator can be seen here. So that's what's going on in the mine. We have also the possibilities, for example, to interact with the barrier cabinets in the simulator, because we realized that to really test the processes and also for educational purposes, it's very much needed to have the simulator at hand, not only for testing. So now both machines are stopped because I have entered here the shared traffic zone. And I can move out then. Again, switch direction. Going backwards is a little bit more difficult because it is all the other way around. And then the first machine starts to enter. And then the second. And now you see I have entered the traffic zone, the same as the other machine is in here. And then we get a zone conflict, which then stops the other machine here. And I removed myself from the shared traffic zone, and then it all continues again. All right, I think that was the presentation and the demo, and now you feel free to ask questions. But I think we have a microphone if you want to ask, so that we can record it properly.
Have any questions?
How much? Yes, no. How much of the control is made actually in the vehicle, and how much is done via the management system? Does it have a constant contact for every movement, or does the vehicle manage itself for instance, to avoid collisions and so on?
Yeah. So what we did, and what is represented by those orange lines, is that we have a conservative approach. So we tell the vehicle it is safe to go until a certain point. And even if the management system would go down, the vehicle would go until that point.
Hi. Hi. How do you track the assets underground, and how do you communicate to the machine in real time?
What do you mean by how do you drive?
Track. Like,
track.
Track the assets.
Yes. Okay. The tracking is by LiDAR sensors, and so you get a local interpretation of the position, and that is also saved in the routes which you pre-record, and then you get more or less a fingerprint of the wall of the vaults of the mine, of the extraction drives, which then is used to localize or to position the machines towards a global map, which is mapped.
What about the communication?
The communication, the communication is through Wi-Fi towards the machines. And there were a lot of problems because I think you have just Wi-Fi access points here down below or in the southern parts here and also up here. So when the machines are in the middle of the drives, then it is poorest, the radio coverage. And you need to have some kind of handover there in this area. And it was a lot of hustle to get the quality good enough so that you have continuous operation.
Thank you.
Anyone else? Okay, thank you so much, Jan-Dirk Weber.
Thank you.
And the next Tech Tuesday was supposed to be held by SICK IVP on the 29th of November, but unfortunately they had to cancel. We are looking for another company to fill their shoes, so stay tuned and we will let you know what happens further on. Thank you so much for coming today.